about the difficulty of the contest. And I think for the next, we need to find easier problems. And yesterday I gave you 3 problems, right? You can do them next week, I think, next Wednesday. So, can you mention your score yesterday? What are your score for problem A and D and C? Okay. All right. Okay, you can join from the other's device. All right, never mind. Let's ignore yesterday's score. And for next week, I think the problem will be easier. And I hope if you cannot got accepted in any problem, at least you can get some subtask. All right. About and then we will discuss some interesting problems as usual. Okay, let me share the link. Have you solved this problem? Not yet. Okay, so please read the problem. You can chat class when you finish reading.
Atau nanti sampai di apa sesampai di hotel jalan kaki 2 meter 3 meter tambangan itu kan 100
Yes, yes, the tag is TP. Okay, maybe Ahmed finished treating this problem. Okay, okay, Thomas finished reading. Position finish. Okay, the input is only N and M. So do you know why the modulo is parametric, not fixed? What is the purpose? Yes, yes, otherwise we can recalculate. Because if the modulo is fixed, for example, 1E9 plus 7, then we can easily find a brute force solution. For example, the complexity is N cubed. So it is around actually if it is N cubed, then maybe we need 100 second, or this is around how many minutes? Maybe 20 minutes, right? Just run the brute force solution 20 minutes. 20 minutes and then put the answer for all n. After that, just hard code everything, right? So we will hard code every answer from n equal to 1 until 5000. And then just input n and then output answer n and just submit it. Okay. But unfortunately, m is given in the input, not fixed. So we cannot recalculate. Okay, then any idea? The size code. Okay. Wait, what is the maximum size code? Okay. Ahmed said that the maximum size code is 2 to the 16, or it is around 65,000. If the modulo is, okay, if it is 9 digit, 9 times you know, n is only 5,000, right? So it is around, okay, but we need comma, right? We need comma, so 10 times this. It is only 50,000. I think the other code no more than 1,000. Yes, that will work. Okay. If m is fixed, but unfortunately m is given in the input, so we cannot do that. All right. So the problem is like this. Given n, we want to make an array with size n, and for each number, for example array ai should be at least 0, at most I. So do you know how many possible array satisfying this condition? How many array A with size exactly n satisfying ai less than I? Yes, n plus 1 factorial. Why? Because there are two possibilities for a1, right? Either 0 or 1. And then there are three possibilities for a2 until n plus 1 possibilities for the last value. If we multiply everything, it is equal to n plus 1 factorial. How about 1? Okay, multiply with 1 is not affecting. So yes, there are n plus 1 valid sequence, right? Okay. And then for every valid sequence, we want to find the score. Let's say f is the score. F for some array is equal to the score of the array. What is the score? The score is the number of ways to remove the tokens, right? The number of ways to remove the token. But how to remove the token? So we will perform n operations. Okay, check. Can you hear my voice? Okay. All right, let's continue. Oh, my Wi-Fi was turned off because the electricity is off. Okay. All right, let's continue. So what is the score of an array? The score is the number of ways to remove the tokens. But the rule is like this. We will do an operations. In operations I, we will check whether AI is equal to 0 or not. If AI is equal to 0, just do nothing. No need to remove any token. But if AI greater than 0, then remove exactly one token in this segment between AI and I. That's why AI shall be less than or equal to I. All right. Okay. For example, if the array is like this. Okay, initially there are 3 tokens, right? Token 1, token 2, token 3. And then initially, okay, for the first operation, just do nothing. And then for the second operations, we must remove the second token, right? A token from 2 until 2, so it must be 2. And then after that, in the third operation, we can remove a token from 1 to 3. So it is up to you, either removing 1 or removing 3. So there are two ways. So the score is 2. What else? Let me give you another example. If the sample is like this, okay, can you predict what is the score of this array? Why it is not valid? Okay. One. I think more than one. Wait, two ways are considered different if okay. So when we remove token 2 and then token 3, and when we remove token 3 and then token 2, they considered as different ways. But okay, yes, I think it is equal to 1, sorry. Yes, because we must remove 1, 2, and then 3. All right. Yes, that's correct. How about 0, 1, 1? How many ways? If there is no token, then it is not a valid removal. We cannot uh, use that configuration. Okay, yes. The number of ways is 4 because you know okay, because for this there are two options, either removing one or removing two, and for this again there are two options, either removing two or removing three, or here either removing one or removing three. Wait, Hasan Arif asked, what if there is no token on segment AI to I? I think there always exists because token I is always exist. Yes, it will never happen because when we are in operation I, the previous operation always less than I, right? So I always exists. So of course from AI to I, at least one token exists. All right. Okay. All right. Any questions? Okay, any idea how to solve this problem? Let me give you some hints. For example, what if n is only up to 8? Can we solve it using brute force? How to brute force this? Okay, how to do that? Yes, check all valid sequence. Of course. Okay. And then but how to check them? If you check them in n factorial as well, then your solution will be n factorial times n factorial. It will be time limit exceeded. How to check in just ON? How to get the score of an array in just ON complexity? For example, n is up to 10. So your complexity should be like this. Don't be like this. Okay. Any idea? Checking the weight. So do you spend victory? I think it is overkill. Or for example, given an array, given a valid array A, we want to find the score. How to find the score in just ON? Any idea? You spend victory? Yes, you can. But how? Can you write down the formula? How do you spend victory? Given n a, calculate calculate fa in, okay, I think on square is acceptable if n is up to 5,000. Okay, as an array as an idea. Okay, for example, let's create a fan victory with size n and all value equal to 1. We can easily find how many value in range ai to I using pref I minus pref ai minus 1, right? And then we remove easily. Which index we want to remove? Which index? Any idea about which index we want to remove? We will remove ai or I. Which one? I think we cannot remove this easily because we don't know which token we want to remove. Okay, so this is not a good idea. Okay, this one got another idea. Okay. This one, can you write down the pseudocode, for example, in this link? Can you explain your idea using a pseudocode? All right, yes. You can try to you can to try you can try to implement it. If it is correct, then you can explain to your friends. Okay. Basically, if we want to find the score, it is just like we want to find the number of array pi satisfying this, right? Number of the number of array p satisfying this, and all p are different. Okay, is it correct? If ai is 0, then pi is 0. Otherwise, pi should be between this, but all p are different. Is it understood? O- Okay, pi is where I think the token removed in ith operation. So pi is token removed in ith operation. Is it correct? So of course, if AI is 0, okay, let's make it pi is equal to 0. Otherwise, pi should be between AI and I, but all p should be different. Alright. So basically, we want to find the number of configuration of array A and B satisfying this, right? Is it correct? Okay. Okay. And then the other idea to solve it using brute force is brute force the array B, not array A. We want to brute force array A. Sorry. Yes. We want to brute force array B. So I think there are around n factorial possibilities, or maybe n factorial plus 1. And then just calculate the number of possibilities for A, right? How to find the number of possibilities for A? Any idea? If given B and we want to find the number of possibilities for A. A can be same. It is not always different. Yes, just product of all P, right? Just product of all P. So it is just like this. If Pi is equal to 0, then just do nothing. So for example, the number of possibilities is initially 0. Sorry, initially 1. If Pi is not 0, then AI, there are Pi possibilities of A, right? Because AI should be less than or equal to Pi. So just do this. Is it correct? So this is the solution with complexity n factorial times n. Just brute force P and then do this. Okay. Any question about this? Okay, how it can be? It is because we want to find the number of A. Okay, so the idea is like this. If we read the statement, we want to find like this. For every valid A, we want to count for every valid B, right? And then answer plus plus. the main problem is like this. So what if we change the problem into like this? Okay, are they same? Okay, it means for every token removal configuration, we want to find the number of array such that this token removal is satisfied. Okay. For example, we want to remove the token like this. We will remove 0 here. We'll remove 2 here and remove 3 here. Okay. How many valid array A? For array A like this, of course it is valid, right? Or if the array is like this, it is also valid. And then for array like this, it is also valid, right? What else? If the array is like this, it is valid. If the array is like this, it is also valid. If the array is like this, then the array is valid. It means there are 6 possibilities, right? If A is like this, then this is one of the valid token removal. Okay. Alright. That's why it is just the product of array P. Because for its PI, there are PI possibilities. PI there are PI possibilities for AI. Because AI can be equal to 1, 2, 3, or PI. Alright. Alright. Any other question? Alright. And then the other idea is like this. You know, there are 2 types of value. Either both of them are 0 or both of them are non-zero, right? Then what if initially we will choose which index is non-zero? For example, C is list of non-zero index. Okay. Do you know what I mean? For example, in this case, the list of non-zero index is in index 2 and index 3, right? Because index 1 is 0. So do you know how many possibilities for C? How many possible list of index? For example, if n is 3, C is either empty or 1 only or 2 only or 3 only or 1 2 or 1 3. or 2, 3, or 1, 2, 3, right? So how do you think? How many possibilities? 2 to the power of 2 to the power of what? Yes, 2 to the power of n. Because it is just like uh, for each index there are two possibilities. Either it is 0 or it is non-zero, right? Okay, so there are 2 to the power of n possibilities. All right. What else? After we get array C, actually we just need to think about like this. For each C, we want to find the value of this. Okay. And then for the other index, just make them equal to 0, right? AI and BI is equal to 0. But for each index in array C, we want to make the value like this. It is just like the previous formula, but we change the index into C. All right. Is it understood? Okay. Any question about this? C is list of index. I mean, for example, there is an array A. The array is like this. Okay, it means C is 2, 3, 5, 6, 7, 9. Okay. So list of index such that A and B is non-zero. Okay. Then, for example, 1 of Ci is 6. Then it means A6 and B6 should be non-zero, right? Should be like this. So for each index that is non-zero, so it is just like initially we want to consider which index will be non-negative. For example, let's consider this index are non-negative and the others are 0. I mean non-zero. Or this index is non-zero and the others is 0. So it means A1 and P1 is 0. A4 and P4 is 0. But A2 and B2 should be like this. Is it correct? And then A3 and P3 should be like this and so on. A9 and P9 should be like this. So it means ACI less than or equal PCI less than or equal CI. Okay. Any question about this? Okay. Okay, let's continue. Then actually we just need to think about the value of C and then since the other index are always 0, actually we can cut the value. We can cut the array. We can just remove the 0 value. We can ignore the 0 value and we just think about the value like this. Okay, so this formula will be easier, right? Practically, we want to find the number of array like this. The size is in any size. The size not always equal to n. Size is between 0 until n. Between 0 and n. After that, we want to find the number of value like this, but p should be different, right? Or all p are different. And c are sorted, right? In sorted and different. So sorted in increasing order. And A is up to you. Not always different, not always increasing, not always sorted. Okay. So basically we want to find the combination of A, B, C satisfying this condition. Is it correct? Do you know what I mean? For example, A is 2, 3. Okay. Or for example, A is 2, 1. B is or let's make it 1, 2. And then this is 1, 3. And C is 2, 3, for example. What does it means? It means A is actually 0, 1, 2. B is 0, 1, 3. Okay. So this one is a valid configuration, right? Or for example, this is 1, 1. Like this. This one is a valid configuration. Okay. Is it understood? Okay. Make sure you are understand why this problem is equal to this, equal to calculating the number of configuration of ABC satisfying this. After we know this, we can easily solve it using DP, right? We can easily use DP. Do you know how to use the DP solution? The DP is just like brute forcing the number of P, and then the number of A and the number of C can be calculated easily. Okay. So let's think about what is the state. So what is the state? For example, the Pij is what? Okay. The number of configuration if P1 is equal to I and the size is J. Okay. Is it understood? if the first value of P is I, and then the size is J. Okay. So what shall we do? Wait. I think we can also change the problem become like this. B should be in increasing order and all C are different. It is just reordering the index from this configuration to this configuration. Because we know that C are different and P are different. For this case, we sort based on C. But if we sort based on P, it will become like this. Is it correct? Okay, I think it is hard to understand. Okay, then just believe me. The problem is equal to this. After that, if we want to solve this, we want to calculate the number of this, then we can solve it using dynamic programming with state like this. dpij, the number of configurations such that the first value is I and the size is j. Okay. So what is the answer? Of course, the answer is the sum for all, I think for all dpij, right? The first value can be any value and the size can be any size, right? Okay, let's say we want to find the sum. I think empty array is also a valid array. So we need to add with 1. Okay. The first value can be from 1 to n. And then the size can be 1 to n as well. Okay. Basically, it is like this. And then how to find the transition? Okay. You know, if the first value is I, okay, and there are j values. Okay, actually, if j is equal to 1, then dpij, do you know how many possibilities? The size is only 1. Okay, we only need to think about one value. And b1 is I, So the number of valid C will be n minus I plus 1, right? The number of valid A is I. Is it correct? Otherwise, we need to think about the next value. Let's say the next value is K. Of course, K should be greater than I, right? So we will find a configuration for dpkj minus 1. After getting the value for this configuration, we will think about the first value. Okay, P1 is equal to I. So there are I possibilities for A1. And do you know how many possibilities for C1? It is just like, basically it is like this, but since C should be different, and there are already J minus 1 possibilities. Sorry, J minus 1 another value. So we need to subtract with J minus 1. Is it correct? Okay. Yes, so this is the transition. And then what is the iteration? We can just simply, okay, since dpi need another greater index, so we need to iterate from the biggest one to the smallest one. Okay. For j, we need smaller value, so we can make it from the smallest one to the biggest one. What are the best case? Actually, the best case is like this, is here. No need to write down another best case. Okay, and then just combine them into one code. The code will be like this. Okay, let's check whether it is correct or not. Okay, what if n is equal to 1? In this one, maximum n. Okay, if it is equal to 1, then the answer is 2. If the input is 2, Wait, what's wrong? Let's question time out. Okay, I think this is K. Sorry, not I. Okay, 7. Yes, it is correct. What if n is 3? Okay, 37. What if this is 4? Okay, 273. If it is 5. Okay, 2672. All right. So this formula is correct. Can you believe it? We can just add modulo everywhere. Okay, any question about the idea? The implementation are simple, right? Only a few lines, I think. Simple. Okay, just try to understand why we can change the problem into like this. After that, why we can solve this using TP like this. Okay, maybe let me explain using the other ways without formula. So the idea is like this. We will find which token will be removed. Okay. Do you know how many possibilities for this? Which token will be removed? So for each token, there are two possibilities. Either we want to remove that or not. And there are n tokens. So how many configurations of remove token? Yes, of course, two power n, right? 2 power n. There are two power n possibilities. Okay. And then, for example, we already fixed which token will be removed. For example, okay, token 5, token 9, token 10, for example. After that, we want to think about when or in which operations they are removed. Okay. For example, which token will be removed is array P, and it is sorted. So the number of sorted array P, of course, there are 2 to the power of n, 2 power n possibilities. All right. And then if array P is fixed, we want to think about this, in which operations they are removed. So for token 10, it can be removed only in operation 10 to n. Is it correct? Before operation 10, it cannot be removed. You got it? Okay. So it means there are n minus 10 plus 1 possibilities, right? Okay. And then let's continue. How about token 9? There are some possibilities from operation 9 until operation n, but cannot in this operation, right? This chosen operation. Because this operation already used for removing token 10. So do you know how many possibilities? Basically, there are n minus 9 plus 1 possibilities, but one of them already used for this, so minus 1. Yes, that's correct. How about this? We can also remove in operation 5 to n, but 2 of them already used. So how many number of ways? Okay, yes, that's correct. All right, so we already think about in which operation we want to remove. All right. After that, we need to think about the array A, right? How many possible array A? You know, A should be less than B, right? Should be less than or equal to B. And A can be equal, so we don't care about the other value because they will not affecting each other, right? So for this, there are 5 possibilities. For this, there are 9 possibilities. For this, there are 10 possibilities. So just multiply it by 5, by 9, by 10. All right. Is it understood? Okay. Okay. Any question? Which part you didn't understand? Okay. Okay. That's why for its index, if we want to remove index I, we want to know how many other token that we want to remove. Or okay, let's back to the TP. Okay, the number of configurations such that the first token we want to remove is token I. I mean the leftmost token, not the first. Not always first, but the leftmost. The leftmost is I, and the number of token we remove is J. Okay, you got it? And then we want to find all possible removed token, right? The number of removed token is either 0, 1, 2, 3 until 9. Sorry, until n. If we remove nothing, the number of ways is 1. If we remove one token, then it is the case when j is equal to 1. If we remove two tokens, it is when j equal to 2 until j equal to n. We remove all tokens. For each token, we will check which token is the leftmost removed token. It is I. So I is just like leftmost removed token, and j is number of removed token. Okay. So the answer is just the sum of all of them. But remember, we can also remove nothing. If we remove nothing, there is only one possibility. Okay. How about the transition? If j is the if j is 1, okay, it means I is the only removed token. So it is just like this. And then what if there is another removed token? So we want to think about which what is the next next token. The next token is from I plus 1 until n. If the next removed token is is k, I think this is k. Then the number of configuration is k j minus 1. And they are not affected with the previous token. Okay. The next token will never affected by the previous token, but the previous token will be affected by the next token, right? Okay. If we want to remove token I, then the value of A is from 1 to I. So there are I possibilities. And then we want to think about in which operation we want to remove this. Actually, there are n minus I plus 1 possibilities, but since we already use j minus 1 operation for removing another next tokens, so we will subtract with this. So this is the transition, and we iterate like this since dpi need another greater value, and finally just combine them. All right, any question about this? So can you solve this problem? How do you think? What shall we do next after we finish this implementation? Yes, add modulo. What else? First, we need to add modulo. For this, it will never exceed. Okay. Yes, we need modulo. So this is M. I think this will overflow. Add modulo here. I think for this it is also enough. 5,000 square. Yes. And that if we add them, it will never exceed long maximum bound. So we get modulo here. Okay. Okay. Any other thing we need to do? Yes, that's correct. The complexity is still n cube. You know, this is for n, for n, for n. Any idea how to optimize this? How to remove this for loop? Okay. Prefix sum. Yes, we can Actually, not prefix because we iterate I from past. Yes, it is suffix. Yes, we can use just like suffix some. Even in my solution, I'm not storing the TP. I just store the suffix. I just store the suffix and then just find the total suffix. Okay. And the formula are same. I times n minus I minus j plus 2, right? I times n minus I minus j plus 2. Because this is plus 1 and this is minus negative 1. And then multiply with suffix. With suffix I plus 1 j minus 1, right? Suffix I plus 1 j minus 1. Okay, so this is the value of TP. If we know the value of TP, so suffix ij means suffix I plus 1 j plus TP. Modulo m, of course. So it is only n squared. And in my solution, if the size is 0, then the number of ways is 1. Okay. Okay, because it is suffix, so it means the first value not always equal to I, but at least I. So it is not equal to I, but greater than or equal to I. That's why the formula is like this. This is the case when the first value is I, and this is the case when the first value is more than I. Okay. Any other question? Simple, right? The implementation is simple, but the idea is not. All right. Any other questions? For that, let's discuss another problem. Anyone solved this before? Not yet. All right. Okay. Please write this problem. Okay. Please read this problem and then think about the solution. Okay. Okay, so the problem is like this. So we want to make Roman digits consisting of n digits. Okay. Okay. So how many different value? Oh. Of course, the smallest value is when all of them are I, and the value is when all of them are L. Okay. And then the idea is like this. Since we know there are exactly n digits, then of course at least for each digits, at least the value is 1. Okay. So at least the number is n. So let the number is n plus something. N plus something. So it means to find what is something, we can just consider like this. The value of I is only 0. The value of P is 4. The value of X is 9. And the value of L is 49. Is it correct? Is it okay if we change the constant like this? Then the answer will be same, right?
Oh iya, lebih dari 4 hari. Lebih
Okay.
enggak.
Any question?
Dan kita semua sholat di rumah.
And then after we know this observation, so there is another observation like this. Value x is valid or can be represented by exactly n Roman digits if it can be represented by 4 times something plus 9 times something, sorry, 9 times something plus 49 times something, and a plus b plus c should not greater than n. Is it correct? Of course, a, b, c should be non-negative. Okay. All right. So the idea is like this. Since it is valid if it is less than or equal to n, we can just try to minimize a, b, and c, right? So we want to minimize b. So it means b should not exceed 49. Because if b is greater than 49, we can reduce b by 49 and increase increase c by 9. It will be more efficient, right? Okay. And also a should not exceed should not exceed 9, because if it is greater than or equal to 9, we can reduce a by 9 and increase b by 4. It will be more efficient, right? Okay. All right. So it means for a plus 9b and only up to 9 times 48 plus 4 times 4 times 8, right? I think it is pretty small. Okay, only 464. Okay, and the other we can just use 49. So we can just brute force or use TP to find for each E what is the minimum A plus B such that for A plus 9B is equal to I, right? And then the other, for that case, we can plus 49, 49, and so on. So it is just like handling 49 cases. The case when x modulo 49 is 0, the case when x modulo 49 is 1, and so on until 48. You got it? Okay. So for each case, we want to find the number of possibilities. For example, if this is zero, of course, minimum a plus b is zero, right? Minimum a plus b is zero. What does it means? So c can be any number from 0 to n, right? What's next? So it means there are n plus 1 possibilities, right? Okay, n plus 1 different values. And then, for example, the case when the modulo is equal to 4, minimum is a plus b is 1. So c is between 0 until n minus 1. So there are n possibilities and different values. Is it understood? And we will calculate everything here. Okay.
Ano buong sabi?
Any question? I think it is simpler. The implementation will be simpler as well. Okay. So this just like this input n, and then for its cases from 0 until 49, the minimum cost is the minimum a plus b is okay. At first, let's make it n plus 1, but we will minimize this. We will iterate from 1 to 9 and from 0 to 49. A I times 4 plus j times 9 modulo 49 minimize with I plus j. Alright. Finally, we just need to do this. Answer plus by n minus ai plus 1. Is it correct? Let's check. Okay, it is 4. This is 10. Okay, 244. Okay, yes, I think that's correct. Okay, any question about this solution? If there is no, so I think that's all for today. Uh, Thank you very much for the discussion, and don't forget to tune the contest on next Wednesday. Mm, Let's close our meeting with praying. Subhanallahumma wa bihamdika, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.